Okay, so let's look at chapter 2H. I'm going to take you through the first example, and then, depending on how long this video gets, maybe the second example, or that might be in a separate one. So these deal with rational functions, which are one polynomial divided by another polynomial, and the second polynomial can't be zero, because otherwise you can't divide by it. Before I jump into the problem, I want you to recall this idea. The division algorithm says if I give you a polynomial, you can always write it as the divisor times a quotient plus a remainder, where each thing there is a polynomial. And then we've also done this before. This is what probably you were more familiar with from last year, which was if I give you a division problem, that's the same thing as taking this whole thing and dividing both sides by d of x. So you're left with the quotient and then plus the remainder divided by the divisor. Okay, so right now we're going to actually use this idea here a little bit. So in this case, I've got h of x equals 3x minus 7 over x minus 2. And the tricky part to this problem is that I give you I tell you f of x equals 1 over x. It's our basic function. What do we do to actually translate it to get it to look like h of x, or transform it? So what I want to do is I actually want to do long division here. And you could do synthetic division. I'm choosing long division just because long division will work for every example that we do in this handout. So if I do long division here, 3x minus 7 goes underneath, x minus 2 goes on the outside, and then I'm going to multiply by 3 to get 3x minus 6. And then when I subtract, the 3x's cancel, and I'm left with negative 7 plus 6, so negative 1. So this says that I can write this as 3x minus 7 over x minus 2, that was the original problem essentially, equals 3 plus, right, because 3 is my quotient, and then plus the remainder over the divisor, negative 1 over x minus 2. So I'm just going to write that as minus 1 over x minus 2. Okay, so let me shrink all this stuff down here. Okay, so if I started with a parent function of 1 over x, the question is, well, how do I turn it into this? That's easier to see the transformations for it. So one of the things I could do, you could do it in any order, but certain orders might be easier than others. I see that the x turns into an x minus 2. So that would be a horizontal shift to the right 2 units. So that changes the x into an x minus 2. Then another thing I notice is that there's a negative in front of the whole thing, in front of the 1 over x minus 2. So if I turn the whole thing negative, that's the same thing as saying a reflection about the y-axis. So that takes my entire function and changes the, wait, over the y? I'm sorry, over the x-axis. Yeah, over the x-axis. That changes the whole y. So now it's going to be negative 1 over x minus 2, where the negative's in front of the entire thing. And then I've got to add 3 to the whole thing. So that's a vertical shift up 3. And so now I end up with 3 minus what I had before. 3 plus what I had before, really. So this is these are my transformations here. Okay, so let me shrink this down a little bit. All right, let's talk about horizontal and vertical asymptotes. So the horizontal asymptote, if I was just looking at 1 over x, right? If I was just looking at 1 over x is the one that looks like this. And it has a horizontal asymptote at 0, and it has a vertical asymptote at 0. But notice what I've done. Now I've moved it right 2 units and up 3 units. So now my horizontal asymptote, instead of being at 0, got moved up 3 units, so it's going to be at 3. And my vertical asymptote, which had been at 0, I shifted everything to the right 2 units. So this vertical red line ends up over 2 units at x equals 2 now. So let me graph this thing. This is the x-axis, this is the y-axis. Remember, now my horizontal asymptote, it's 3 units above where it used to be. So now it's at y equals 3. And the vertical one is now at x equals 2. Let me make this look a little more like 2, if that's 3. X equals 2. And, whoop. And before, y equals 1 over x looks like this. But remember, I did one other thing. I reflected over the x-axis. So instead of this one here, if I reflect over the x-axis, it ends up down there, and then I move it up 3 units. So this is going to look like this here. And then the other one gets flipped over and then moved up 3 units. So it's going to be over here. Remember, and everything got shifted over 2 as well. So there's our picture. I'll put the other example in a separate video. But make sure you watch both of them.